you're going to start with the properties of logarithms notes. We'll get to the reference sheet in just a minute. So yesterday we learned some basic things about logs and how to convert to and from exponentials and so forth. So today we're going to look at how some of the properties of them when we want to expand, condense. We're going to eventually be solving with them and all that good kind of stuff. So we got to know some other things about them. All right, so we have what's called a product property. If I have a log of any base and the argument of the log is a product of some sort, then I can split that into two logs, and I can make that log base b of m plus log base b of n. Okay, so your multiplication becomes addition. And then it works backwards as well, meaning that if I have these two that are being added that have the same base, I can condense it to one and multiply those two arguments together. Okay, so let's see how this works. We are going to condense into a single logarithm. So on number 1, I have log base 3 and log base 3. So first of all, you have to have the same base, and we do. Since we are adding them, we can condense it to one log, so it can be log base 3 of 9 times 5. So that gives me log base 3 of 45. Easy enough? And you'll see why we need to expand and condense. Right now we're just learning like the one step at a time, and then we'll put it all together tomorrow. So on number 2, log 6 plus log of x minus 3. And notice the x minus 3 is in parentheses. Anytime you have more than one term, it's got to be in parentheses. And so this can become log of 6 times x minus 3. All that has to be in parentheses like that. And then I need to distribute, so in the end this gives me log of 6x minus 18. Any questions at this point? All right, then you do number 3. Have a better picker today. So I don't think Nabil is on here. Yeah. So there we go. Gwyneth, tell me, what did you get for number 3? Okay. So what do I write? Natural log of what? Plus 3x cubed? Okay. Okay, times 3x cubed. All right, good. So then that becomes natural log of what? Yes, very good. Thank you. Any questions about that? Okay, so that's condensing. Now we're going to expand. So if I have, and it says expand, use the product property. So that means I need to think of 72 as a product of two numbers. So just give me two numbers that multiply to give me 72. 9 and 8. So we'll use that. So this can be the log of 9 plus the log of 8. Now there's more than one answer. And right now we have no direction as to like which one we might want. So there can be more than one answer for sure. What's another set of numbers that multiply to give me 72? 2 and 36. Oh, okay, I heard 18 and 4, and then I heard 2 and 36. I'm going to go with 2 and 36 just because I heard it first, but yes, that works too. So log of 2 plus, oh, if I can write correctly, log of 36. So really any of those, and in a question like this, you would not have to give more than one answer. I just want you to understand that there's more than one answer. And let's say that we were actually using this to solve something and I was trying to cancel out a log of 2. Then I would definitely want to choose this one because then that introduces a log of 2 in there without making stuff up, right? So that's why I know it seems kind of random, but it would have a purpose. All right, so then natural log of 9 over 10. What's 2 numbers I could use there?
9 and 1 over 10.
That works, thank you. So I could do the natural log of 9 plus the natural log of 1/10. That totally works. What if I had the natural log of 3/10? What would the second one have to be? Maybe what? 3 over 1, which you could just have as 3, and that's fine. That's absolutely fine. But it's not 3/10, and I had a hard time getting some people at last period to understand why it was not 3/10. If it's 3/10, then I end up with 9 over 100, but just a plain old 3 works just fine. And again, one of those answers isn't better than the other, it's just there's more options there. And the first one is the simplest. There's no reason to make it complicated unless you know you need a specific number. All right, so number 6, since it's telling me to use the product property, I need to make this into some sort of product because right now it's a difference. But this little thing, what is this called? Oh, close. It's the difference of squares, yeah. So it's the difference of squares. So this is log base 5 of, and then x plus 2 times x minus 2. So now I have the log of a product, and that can give me log base 5 of x plus 2 plus log base 5 of x minus 2. Okay. Any questions at all about that? All right, so that's your product property, condensing and expanding our logs. So now we're going to look at the quotient property. So if I have log base b of m divided by n, I have a quotient right here. So the product split into addition, the quotient's going to split into subtraction. So this is going to be log base b of m minus log base b of n. And vice versa, meaning if I have subtraction, I can change it into a quotient. So that's what it's asking me to do in number 7. I have the natural log of 96 minus the natural log of 6. So that's a difference. So that means I can make it into the natural log of 96 divided by 6. Then I have to simplify that. It's 96 divided by 6. Good. 6 goes into 9 once with 3 left over, and that makes it 36, so it's 16. All right, y'all go ahead and do the next one on your own. Angela, when you're done, you get to walk me through it. Okay, so what do I do? Okay. Very, very good. Thank you. Everybody good with that? Awesome. All right, so we're going to do 9 together because I'm afraid some of y'all are going to make stuff up with your square roots. So I've got 2 logs, same base, and I'm subtracting, so I can make that into division. So this is going to equal log base 7 of the square root of 40 over the square root of 5. Now, I could rewrite that. I'm not going to because I don't have to, but I could rewrite that as just the square root of 40 over 5 because it's the same thing, which means that since all that stuff is like all underneath the square root together, I can reduce that fraction and it becomes log base 7 of the square root of 8. Okay, because anything underneath the square root you can reduce, anything outside the square root you could reduce. I get that. But I don't get to leave it as the square root of 8. I have to simplify that. So this is log base 7. What's the square root of 8 simplified? Square root of what? 2 square root of 2. Very good. All right. Any questions about that? All right, so then we're going to expand using the quotient property. So again, I have to make 8 into a quotient. Like I have to think about give me 2 numbers that would divide to give me 8. It's okay. That's all good. So I know sometimes, hey, first thing that pops out of your mouth, you're like, what? But you caught yourself. I mean, yeah. 16 and 2. Okay, so I can make this into, it's all good. I can make this into the log base 3 of 16 minus the log base 3 of 2. Hey, I'd rather you participate and say something wrong and ridiculous than just sit there and stare at me, so you're good. But remember, the reason we might be expanding something like the log base 3 of 8 is because maybe we need to get rid of something. Maybe we need to introduce a specific log for a specific reason. So what if I had log base 3 of 48? What would that become? It's fine. I figured. Come on, you're good. Log base 3 of 48 minus log base 3 of what? 6. Yes. Oh, what's happening here?
Your Zoom crashed.
My Zoom crashed. Okay. All right. I hate when this happens. So I don't know how to get rid of it. There we go. Okay. Am I back? Can y'all see that? Hi.
Yes.
You can? Okay. Oh, I crashed again. Yes. You're awesome. Thank you. I think I just crashed again. Crap. Okay. Well, we'll see what happens. I don't know. I don't know why I keep crashing. Okay. Let those people in. All right. But y'all can see me again? Yes? Okay. Sorry about that, guys.
Yeah.
All right, I don't know what's going on. It's just has a mind of its own right now. Okay. So, all right, back to this problem then. Log base 3 of 48 minus log base 3 of what? 6. Yes. For those of you that just joined the Zoom, we're on a different schedule today. So I understand that you probably didn't know that, but that's why you've missed the first part of this. Just make sure that you go and catch it on the video because it's important. All right, so now we're going to expand this one. And there's options here as well, but I mean, we may as well not make it more complicated than it needs to be, right? So I can just do the natural log of 3 minus the natural log of 4. Everybody okay with that? Does 12 look like it's pretty simple to split up as well? Yep, so we'll just go ahead and do that one together. This is just going to be the log, and you have to have parentheses, x minus 7 minus the log, parentheses, x plus 1. Okay. Any questions at this point? Alrighty. So let's look at the power property. Log base b of m to the nth power. So if I have an argument that has an exponent on it, this exponent just comes out front. It's no longer an exponent, and you multiply. So I pull this out front, and it becomes n times log base b of m. And so remember, we can go backwards as well to condense. We can condense or expand. So on 13, that 3 times the log of 6, this 3 can just come up here and become an exponent. So this becomes log of 6 to the 3rd power. But then I need to calculate that. And that's one we should know or be able to come up with pretty quickly, because when you're using cubic stuff, 6 is used a lot. Anybody know what that is? 216. Yes, thank you. 216. I heard that over here too. Good. So log base 6 of 216. All right. Then on 14, I've got this 1/2 out front. It's going to come up here and become an exponent. So this is going to become log base 4 of 81 to the 1/2 power. So what is another way of saying 81 to the 1/2 power? Square root of 81. And what is the square root of 81? 9. So this is log base 4 of 9. So by condensing that one, it simplified it kind of nicely, right? So then on 5, this x minus 1 becomes the exponent. So this becomes the natural log of 4 to the x minus 1 power. And there's nothing else you can do with it. As much as you may think you don't like things with variables, because it's a variable, I can't take it to the next step like I could with these. So it actually makes it easier. And I'm done. Any questions at all? So then 16, I have log base 2 of 5 to the x. My x looks like a blob, but I'm pretty sure that's an x. So I'm just going to take that exponent, bring it out front. So this gives me x times log base 2 of 5. And that's it. (17), I don't have an exponent, so I need to make this into an exponent. So the natural log of 2x plus 1 to what power? If this is a cube root, it becomes a what? 1/3. Very good. And then that 1/3 comes out front. So I get 1/3 times the natural log, still need parentheses, 2x plus 1. So then on 18, again, I don't have an exponent, but I need to make my base as basic as I can. So I'm going to leave this as log base 6. But then this one, yes, 8 squared is 64, but I can make it even smaller. I can go all the way down to 2, right? So if I use 2 as my base, what's one thing I know for sure about my exponent? It's going to be negative, exactly. And then it's going to be negative what? And counting on your fingers is fine. It's how I do it too. Yeah, 2, 4, 8, 16, 32, 64, right? So it'll be 6 actually, right? Am I right? 6? Now you got me questioning myself. 6. Did I count on my fingers right? So then I can bring that out front, and I'm going to get negative 6 times log base 6 of 2. Okay, any questions at all from me, anybody? Make sure I got everybody that came in. Okay, so we still have the reference sheet to look at. So if you will pull that up. And we're going to kind of put all this together. All right. So we have a common logarithm. So your common logarithm, base 10, is just written as log of x, and we don't have to put a base there. Right? Natural logarithm, base e, written as the natural log of x. Okay. So this is all just kind of putting together everything we've had. So if you have one reference sheet, this would be a good one that kind of has everything on it that you need. All right, so some basic properties. Log base b of 1 equals, so no matter what the base is, if I take the log of 1, what am I going to get? 0, because b to the 0 power gives me 1, right? B to the 0 power gives me 1. What do you think log base b of b is going to give me? 1, because b to what power gives me b? Well, it would be b to the first power, right? So log base 10 of 10 is 1. Log base 70 of 70 is 1. Like, if those two match, it's always going to give you 1. So log base 6 of 1, anytime you take the log of 1, you get 0. Log base 4 of 4, if these two numbers match, you get 1 every time. Those are important things to know because that's going to help you graphing and help you realize some, easy things along the way. All right, so we're going to restate the product property. So the product property becomes addition, so this becomes log base b of m plus log base b of n. Then we'll have an example of condensing and an example of expanding. So condensing, we just multiply, so that's going to give me log base 3 of 24x. Before I can expand this second one, what do you think I'm going to have to do? Factor. Yes. So I'm going to have to factor, so this is going to give me the natural log of, and then I'm going to have two binomials in here, x and x, plus and minus. So what are my two numbers here? Yeah, positive 1 and negative 2, right? All right, good. So then now I actually have a product in there, and I can split it up. This becomes the natural log of x plus 1 plus the natural log of x minus 2. Any questions at this point? Okay. Quotient property becomes subtraction, so log base b of m minus log base b of n. So to condense this one, it's going to become log of 80 over 16. So to divide that, here's an easy way to think through this. I can divide them both by 2. That gives me 40 over 8, and then I know 40 divided by 8 is 5. I don't have to actually divide 16 into 80. Then to expand them, I just change it into subtraction. So log base 2 of x minus log base, almost put base 5, base 2 of 5. Any questions? I mean, we're just restating what we did. So then we have the power property. So my exponent comes out front. This becomes n times the log base b of m. So to condense this, I can bring this 3 up here. So this becomes the natural log of 9 to the 3rd power, which is the natural log of what? 81 times 9. That's not really even a difficult one to kind of think through. Just think about it. If I have 81 times 9, 9 times 8 is 72, so that's 720, and then 9, so it's just 729. There you go. Then to expand it, my exponent just comes out front, so I get 2x times log base 7 of 3. Change of base formula we talked about yesterday, but I wanted it on here so you have everything all in one spot. And so this is different than the quotient one, because the quotient one, it's 1 log and you have a fraction. This becomes a fraction with a log in the numerator and a log in the denominator. So it's a completely different thing. These are both base 10. Then the base goes on the bottom and the other one goes on top. So it's super easy to do. Change this into a log, and a log. So 138 goes on top, 5 goes in the denominator, and then this one, get a log and log, 14 in the bottom, 2 in the top. And I cannot reduce these. If this was the log of 2 over 14, yeah, I could make it the log of 1 over 7, but that's not what this is. This is the log of 2 over the log of 14. And so those are each their own separate individual numbers. No reducing here, like that is it. Okay. What questions do you have? All right, your assignment today is not in Delta Math. It's in the Schoology folder. So it's a CAMI assignment, or if you print it out, that's fine too. Just make sure that you submit it as a PDF. And you only have to do the evens. And when you open it up, it's formatted like the notes, but it's not the notes. Somebody freaked me out last period. They're like, it's the notes. I said, oh, Lord, I messed it up. But no, it's not. And there's a place for your name. It clearly says it's the assignment, but it does have the same look as the notes. Okay, and you only have to do the evens. Any questions at all? Awesome.